Hello learners, welcome to NIOS Studio. We are discussing about communication systems. Today's topic is satellite communication. When we talk about satellite communication, it's a kind of wireless communication. Let's go into details of satellite communication. In this particular topic, you will be able to describe what satellite communication is, how satellite communication occurs. You will be able to describe various types of orbits which are basically used for the satellite communication purpose, and these are geostationary, polar and highly elliptical orbits. Let's begin with what a satellite is. We all have seen these satellites which are going around the earth. So basically, satellite is a heavenly body which goes around the earth. Now these satellites play a very important role in the wireless communication system, especially the broadcasting network. So in the broadcasting system, we want to spread the information globally from one end of the earth to the other end of the earth, and the satellite communication is a very important mode of wireless communication. Looking at the diagram for the satellite communication, we see over here a transmitter which is giving out the signal, and this transmitter gives out signal which goes up into the space. Over here, the satellite receives the signal, amplifies it, and then it sends back to the receiver. Since the satellite is at a very height from the earth, therefore it covers most of the earth very easily. So over here, what we see is that a modulated carrier wave is beamed by the transmitter towards the satellite. This process of sending the carrier wave to the satellite via the transmitter is called uplinking. The satellite receives that wave, amplifies the signal, and then retransmit to earth at a different frequency. It is done at a different frequency so that the signal which is being sent doesn't interfere with the signal which is transmitted back from the satellite. This process is known as downlinking. So as shown in the figure, there is this uplinking process where the transmitter sends it to the communication satellite. The satellite then changes its frequency slightly and then sends it down, and that process is known as downlinking. So with this uplinking and downlinking process, the satellite communication takes place. Once we have this satellite communication process, the whole network is received from one end of the earth to the other end of the earth. Various types of satellite orbits are used for these communication processes. We have seen this satellite communication as a very common mode of communication while we are broadcasting the television network or other such communication systems. Different types of satellite orbits which we are using, let's go into details one after the other. So some of the common type of satellites which we are going to talk about. Let's first of all talk about a geostationary orbit. When we talk about a geostationary orbit, it is basically an orbit whose revolution period is 24 hours, which means that the rotation of the earth and the revolution period of the satellite or that particular orbit is identical. This makes the position of the satellite exactly the same with respect to the ground station, which means that the satellite with respect to the earth will always maintain the same position, because as the earth rotates, the satellite also goes around with the rotation of the earth. So the revolution of the satellite and the rotation of the earth matches exactly. Thus, the ground stations are able to transmit to the orbiting satellites that amplify the signal and retransmit it back to the earth at a slightly different frequency. If the satellites were not in geostationary orbits, then their motion across the sky, it would have been mandatory to adjust the receiver or the antenna continuously so that the signal is received by them. These geostationary satellites form the basis of the communication system. So, the whole broadcasting network we are observing these days is possible because of the geostationary satellites. The usual height of the geostationary satellite is around 36,000 kilometers. So, they are stationed at a greater height with respect to the earth. So, over here the surface of the earth is totally visible. So, whatever signal comes down, it covers most of the earth. Other than the geostationary satellite, we have polar circular orbit satellites. A polar orbit is one in which a satellite passes above or nearly above both the poles of the body being orbited, which means that if it is the earth, then it passes through both the poles of the earth. This particular orbit is inclined at an angle of 90 degree. These are not positioned at very great heights, so they have a height of about 1000 kilometer and they almost pass over the poles. Usually these satellites are for monitoring purposes. The orbits are usually circular or they are slightly elliptical. A satellite which is in a polar orbit will pass over the equator at a different longitude on each of its orbits, and therefore these polar circular orbits are usually for monitoring purposes, which means that they are not basically for communication, but they are for monitoring the same area time and again. So, what happens is they complete their rotation, they complete their revolution one after the other, and intermittently they keep rotating over the given area and collect information from that area. So, suppose they have a revolution period of 2 hours. So, every 2 hours they are going to look for that same area and they are going to observe the changes in that area within a time span of 2 hours. So, these polar circular orbits, the satellites in these orbits are basically meant for all kinds of monitoring purposes. There are another kind of orbits which we basically have, and these are highly elliptical inclined orbits. The highly elliptical inclined orbits are orbits which have very high eccentricity. These are usually the ones which take round of the earth in highly elliptical orbits, and they are usually at an inclination of 63 degree. These are used in communication at high altitudes. The reason being the geostationary orbits cannot serve the high altitudes because of the altitude from the ground sites being too low, and that is why these highly elliptical inclined orbits are used in place of geostationary orbits at high altitudes, that means close to the polar region, to collect or to communicate near the polar regions. They can be easily used for all kinds of communication purposes. So, over here we have talked about these 3 different orbits, the first one being geostationary, followed by the polar orbit and the highly elliptical orbit. Now, one of the satellite which is being launched is the EduSat. The EduSat is an education satellite which is being launched by ISRO in September 2004. It basically operates in a Ku band which is around 12 to 18 megahertz. This satellite is primarily used for internet based education, educational radio and television broadcast. For example, the NIOS is also using this particular satellite to launch its various programs. The EduSat has a capability of launching around 72 channels. They can be used for regional educational programs also. Thus, one of the common usage of these satellites is using them for various educational programs, just like NIOS is doing it right now for all of you. In this particular topic, we have talked about the process of satellite communication, how the satellite communication process helps us in receiving the signal from one end to the other end without any guided medium, that is via air or space. We talked about various orbits used for communication, and these were geostationary orbits, the polar orbits and the highly elliptical orbits. Of this, the geostationary and the highly elliptical orbits are used primarily for broadcasting communication, and the polar orbits are used for monitoring purposes. So, this is all we have done in this topic. Thank you, learners.